Hello everyone, I'm Mr. Moo from Smakoon Technology. Today I will bring you the sixth section of the operating system, the meaning of each action in programming. First, on the main programming interface, we can see 12 actions on the right. Let's explain them one by one. First is the axis action. After clicking the axis action, we can see that we have 3 axes are currently enabled. Select the x-axis. The second register is the distance it wants to move. Select the distance position as 50. The percent sign defines its speed. We set its speed to 50%. This is the time to wait. We usually set it to 0 seconds. Here, there are reference variables. We will explain it later. Relative motion. Synchronization means multiple axes start simultaneously, but not at the same time. The blocked line means the current one to be blocked, and these 4 functions can be selected. Input X to stop immediately. Output Y to a certain point, output Y in advance, and end the position in advance, and enter the next line. We will demonstrate them one by one. First, we move the x-axis to 50. The second one, we move the x-axis to 0. Then let it output Y at a certain point. Turn on. Still on the x-axis, let it return to 50. Let it end the position in advance. We advance 30. And then, the second function is the waiting and detection. Here, we have 2 options. One is simple delay. If this is a simple delay, you can see that it delays for 1 second. For waiting, for example, we can select the point X we just defined. Wait for us to wait for X1, and rotate to the original position without time limit. We can choose on and off here. The third function is to stack. Let's just put one down first, and then we will introduce a detailed introduction to stacking. The fourth function is a counter. Generally, we use the counter to add 1. It is used in conjunction with the stacking group. The fifth function is synchronization. Synchronization is actually in the axis motion, can be called together. For example, if we select an X and Y here, move to 50 together. And check the synchronize box. You can see that a total of 4 lines pop up here, which are synchronization start, movement of the x-axis, the y-axis movement, and the synchronization end. The sixth function is annotation, which is the current line. We can give it a random name, such as start. The seventh function is stacking. We won't explain this in detail in this issue. The eighth function is signal output. We have 2 types of output. One is a normal output, and the other is time output. There is also an output relay. If we output a normal medium voltage first, relay, this is for us in complex. We will call it in the programming. Currently, our ordinary output is to output 1. For example, Y0, finished product paint. Y1 output a finished product paint bar 2. The ninth function is our label. The label is actually a block call. For example, if we define label 0, and then we jump to each line, and jump to label 0 unconditionally. Then we can jump directly from line 15 to line 14. If there are many lines in between, then it will jump to a whole block. The 10th function is a timer, which can be used to time. In terms of handing over to the pilot, it is not widely used. The 10th and 11th functions is a subroutine of ours, which is to call a subroutine. Let's say we can put this named as a finished product. Put finished products. After that, we can go to the subroutine to edit the subroutine 0. The last function is alarm detection. This means starting on a certain line. Okay, generally, we also detect the sliding table. When the slide table is detected as on, an alarm will be issued. Start signal detection, and when we don't use it, when we don't use X0, we will end it in the next line. End the slide table detection at lines 17 and 18, currently at lines 17 and 18. That is to say, between the start signal detection at line 17 and the end signal detection, we will keep running this. Run this X0 detection connection. It will alarm these 12 simple functions. I have finished introducing them. Later, we will conduct a drill. In addition, if we want to configure an output to a pulse signal, we can select the output time. Select the output time. The corresponding output time. For example, if Y0 is output for 1 second, then when outputting Y0, we will only output for 1 second. If it is 0, we default it to a set signal. Long-term output. Now we go back to this Y0. We can see that, when we click Y0, it will automatically reset after 1 second. Before the demonstration, we can see that, in the upper right corner of the editing page, there will be a prompt that a task has not been downloaded. The main task has not been downloaded. We also edited the subroutine 0. Subprogram 0 is for everyone too. A soft jump demo. It will output a Y4 and then delay for 5 seconds and wait on this page. After we have finished editing, we need to click the download button below. Then a yellow interface will pop up. Wait until the yellow interface disappears to prove that the download is successful. After downloading the program, we need to adjust it to automatic. Our program, by default, when entering automatic mode for the first time, the speed can only be 30%. For safety, when adjusting the machine for the first time, we usually give it a speed of 1%. Then we can click Start here and start running automatically. We can see that the target position of the X-axis is approaching 50 after running the first line, and then returns to the second line. After running the first line, and then the third line, we can see that there is a 30-second early end. When it reaches 20, it will go to the fourth line. Delay 1 second. Meanwhile, the X-axis will continue to move, because there is no sensing signal now, so the X1 rotation to the original position cannot be waited. At this time, if we are in the process of debugging, when there is no signal, and we have this action, we can rotate it back first. Click Edit on this line, and click on the shield row, and then re-download it. Oh, Y10 is output. We can take a look. There is an output Y10 in the second line. To see if our output is output. Oh, Y10 is the output. Let's reset it. And then run the automatic again. The fifth line has entered a gray coordinate state. It has been blocked. Let's delete the docking group first. We will talk about the docking group as a separate section. We can see that we have been a loop here. We are showing you this program. We can see that Y10 is output, and the finished cylinder is also output, okay? This is a basic and simple action process.